Ok, continuiamo a parlare di intelligenza artificiale perché è un po' un tema che scotta, è un tema che sta andando alla velocità veramente della luce. Ogni giorno ci sono delle cose nuove, delle novità. E in questo caso vi racconteremo veramente una bomba incredibile. Ci sono delle novità pazzesche. Stiamo parlando dell'incrocio fra tecnologia e biologia. Stiamo parlando di intelligenza artificiale e di riprogrammazione cellulare parziale. Che cosa vuol dire? Ce lo spiega lui, il Principal Investigator and Director of Computational Biology di Altos Lab, Simone Bianco da San Francisco. A te Simone.
Thank you. Okay, let me get closer, I think. All right, by show of hands, how many people have used AI today? All right. What did you use it for? Shout it at me. What was it? What was it? Okay. So I think each of you knows how to use an AI today. There are thousands of applications, I think, every day. But I'm pretty sure you don't know the applications I'm going to tell you about. All right, let's take a step back. The last, I want to say 15 years have undoubtedly been the years of computer science, and we have seen the rise of artificial intelligence, right, with what we see today with our large language models and GPT and everything that you use today in your smartphone, for example. But I would argue that the last 20 years have been the years of bioengineering and synthetic biology. Synthetic biology is that discipline that starts from biology, from a biological system, and tries to re-engineer it so that that's something that is useful for us. And maybe you don't know, but you are using the products of that every day. We make drugs with synthetic biology, anti-malaria, for example. We make cosmetics. We can make food additives. We even make plastics. Biopolymers are made through synthetic biology. It's an industry. It's a $100 billion industry, one of the largest. And yet, synthetic biology is an art just as much as a science. Let me tell you how it works. So if you have a cell, for example, yeast, that we use for very useful application like making beer, right? You can take a piece of something else and put it into yeast, and then hope that it will produce something for you, a chemical, a drug, right? However, this may not work, right? We try it many times, and when it fails, we just throw it away. There's a lot of trial and error in synthetic biology and bioengineering. This is really not how a $100 billion industry should work, right? So there must be a better way. There is a better way. And although the problem is complex, we know that there is a better way. So a few years ago, I had a crazy idea. Can we build a biological system using artificial intelligence? Now, this is much deeper as a question than superficially it will look like, because what we need to do is to teach an algorithm, we need to teach a machine the rules of life, the language of life. There are over 20,000 genes in our body. These genes are modulated to produce what we are. The fact that we are different is due to the modulation of all these genes. And the same is true for our little single-cell organism, yeast. Yeast shares about 50% of our genome, which explains many things, if you ask me. But these are the problems that AI can help us solve. The complexity is staggering. But this is what AI does, right? It takes humongous amount of data, sift through it to identify patterns, and then we can use to solve tasks. This is how it predicts the next word when you use ChatGPT or any other GPT. And so a few years ago, with some friends, we had this idea. At that time, I was working on immunotherapies. So I was working on cancer, basically, and immunotherapies have risen up in the last 20 years as an alternative therapy to the traditional chemotherapy and radiotherapy. The way immunotherapy works is the following. You can take a cell from a patient that has cancer and then re-engineer it so that it is more active. And then you re-inject it in the patient. It's really futuristic as an idea. The immunotherapy I was working on was called chimeric antigen receptor T cells, and it works in this way. You take a T cell, which is an immune cell from a patient, then you take parts of genes from another cell that are known to act against cancer, and you just put them inside in various combinations. So you can put 1, 2, 3, 4. This is crazy, right? And the complexity, as I was saying, is staggering. The number of combinations that you can find is staggering. This is what AI is very good at doing. And so what we did was we taught this artificial intelligence the language of immunotherapy. Each of these motifs, they are called, parts of genes, genetic material, is a word. You put words together, you create a sentence, you use a syntax, just like we do in Italian or in English. The meaning of this sentence is the action of this cell. Will it kill cancer? Will it be toxic? Will it proliferate? It was a multi-year process and a multi-year project with many people, and it worked. It was absolutely fantastic. We published a couple of years ago in the journal Science. But what was important to me, apart from, of course, the fundamental application to cancer, was the fact that we could teach. It was a proof for me that AI can understand life, that AI can produce life, can design life. Think about evolution. Evolution is this 4 billion years experiment that nature has produced. And so you take evolution, you take something out of evolution, you teach a machine to create something that has never been created, that has never existed, something that is outside of evolution. We do that every day. It's absolutely mind-blowing. So today I don't work anymore on cancer. Today I work, as you were hearing, on this new technology called partial reprogramming. I work for a company called Altos Labs. And our mission is to make people live healthier for longer. Wouldn't it be great if we still lived up to 85 or 90 years old, but instead of spending the last 20 years with joint problems or neurodegenerative disease, we could live a happy life, a healthy life. Partial reprogramming is a way to try and do that. It does more or less what I was describing before. It takes a cell, one of our cells this time, and reprograms it so that it's more resilient to perturbation, to disease. It can protect you from stress. It can stop things that are harmful to us. So we use AI for that. We use AI to re-engineer our cells so we can live healthier. Let me conclude with a but. AI is great, but it's not the only answer. Let me make an example. So go to your favorite image generator algorithm, DALL-E, whatever, and ask it, please make a teddy bear on a horse in space. Funny, right? So it will generate an image of a teddy bear, riding a horse in space, right? Now imagine that image that it creates, in the image that it creates, the horse has 5 legs, or the teddy bear has 3 ears or 3 eyes. Now you look at it and you say, ha, that's funny. Well, now imagine that is a molecule. That's not funny anymore, isn't it? If it is something that we have to inject into people, if it is something that we have to use for healthcare and life science, we can't afford an AI that generates a horse with 5 legs. This is the problem of hallucination. You probably know about it without even knowing the theory behind it. It's this horse with 5 legs. And so there are other ways. We can combine AI with other algorithms. At Altos, what we're trying to do is to add what is called context. We make context-aware AI. We add mechanism. We add to the algorithm what we know about the biology. This is a set of algorithms called hybrid AI that combines what you know, for example, the language models, with what is known about the biology, so that the algorithm actually learns the real biology, the biology we learn, and at the same time is capable of inferring the biology we don't know from the data. Because, it's really, really fun, in my mind, to go online and get that, the horse and the teddy bear. But I think it's even more fun and more important when artificial intelligence helps us live longer, live healthier, live a better life. And that, I think, is the future of AI. Thank you.
Oh, all the time, I mean. No,
I'm waiting for somebody, I think.
Eccomi, grazie Simone. Grazie Simone. Scusami, eravamo con il Prophet of AI a commentare quanto la tua ricerca veramente è interessante, ma per te c'è un premio importantissimo del WMF.
Grazie, grazie, grazie.
Grazie. Grazie mille.
Grazie.
Allora.